Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Understanding AI Architectures. Designing Efficient Systems. Imagine you're building a house. You don't just start nailing planks together, right? You need a blueprint. In AI, an architecture is that blueprint. It's how we design and connect all the pieces that make an AI system work. For us developers, understanding this is key to building AI that actually solves problems efficiently and effectively. We'll learn to design smart systems, not just use pre-built ones. Every AI system needs three main things. Like baking a cake. 1. Data. Ingredients. This is the raw material, pictures, text, numbers. Your AI learns from this. As a developer, you'll be thinking about where this data comes from and how to prepare it. 2. Model. The recipe. This is the brain of your AI. A set of instructions or mathematical equations that learns patterns from the data. You're not writing every instruction. Instead, you're designing the asterisk structure of a brain that can learn. 3. Algorithm. The baker, chef. This is the process or method the model uses to learn from the data and make decisions. Think of it as the how-to guide for making the recipe work. As a developer, you choose the right baker for your recipe and ingredients. Just like there are different types of builders for different projects, there are different AI architectures. 1. Rule-based. Simple instructions. If it's raining, take an umbrella. You, the developer, write all the rules explicitly. Great for simple, predictable tasks. 2. Machine learning. Learning from examples. Instead of telling the AI every rule, you show it many examples, and it figures out the rules itself. For instance, showing it many pictures of cats and dogs until it learns to tell them apart. You pick the learning method. 3. Deep learning. Advanced learning. A powerful type of machine learning, especially good with complex data like images, speech, or text. It uses neural networks structures inspired by the human brain to learn even more intricate patterns. You're essentially building a more sophisticated learning machine. Let's look at the flow. Think of an AI system like an assembly line. 1. Data pipeline. Collecting and cleaning. This is where you gather raw data, clean it up, remove errors, fill gaps, and format it so your AI can understand it. Developer task. Setting up automated processes for data handling. 2. Training. The learning phase. Your model studies the prepared data, adjusting itself to learn patterns. This is where the magic happens, and your model becomes smart. Developer task. Choosing the right training environment and optimizing the learning process. 3. Evaluation. Testing. You test your trained model with new, unseen data to see how well it performs. Is it accurate? Is it making good decisions? Developer task. Designing metrics and test cases. 4. Inference. Deployment. Putting it to work. Once trained and evaluated, your model is put into action, making predictions or decisions in the real world. E.g., recommending a product, identifying spam. Developer task. Integrating the model into an application or service. Why does efficiency matter? Cost. Running powerful AI models can be expensive. Electricity. Specialized hardware. Efficient design saves money. Speed. Users expect quick responses. An efficient AI delivers results faster. Resource use. Less memory, less processing power means your AI can run on more devices, even small ones. As a developer, you're always asking, can this AI do the same job with less? This means choosing the right model size, optimizing your data handling, and using efficient algorithms. It's about optimizing for compute, memory, and energy. Let's build a mental image of an AI architecture for a spam detector. 1. Data. Collect thousands of emails labeled spam or not spam. 2. Data pipeline. Clean emails. Remove weird characters. Standardize text. Convert words into numbers your computer can understand. 3. Model. Choose a machine learning model, e.g., a simple classifier. 4. Training. Feed the labeled email data to the model. It learns which word patterns usually mean spam. 5. Inference. When a new email arrives, your trained model quickly analyzes its words and predicts if it's spam. Then moves it to the junk folder or inbox. Developer role. You'd write the code for data processing, choose and configure the model, and integrate the final spam detector into an email client. What happens when your AI needs to handle millions of requests? 1. Scalability. Your architecture needs to grow without breaking. This means using cloud services, parallel processing, and efficient database designs. 2. Monitoring. How do you know if your AI is still performing well in the real world? You need tools to monitor its predictions and retrain it if needed. 3. Ethical considerations. Is your AI fair? Is it biased? Responsible AI design is paramount. This is just the beginning. Understanding these architectural concepts empowers you to move beyond tutorials and start designing truly impactful, efficient AI systems. You're now equipped to think like an AI architect. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.